Kuzampula. Welcome to Bhutan e-learning program. My name is Mohan Chetri, and today I'll be taking you through chemistry relation for key stage 5, that is for class 11 and class 12. The topic that we are going to learn today is substitution and elimination reactions of haloalkanes. The objective, by the end of today's lesson, you should be able to define haloalkane, describe the nature of carbon-halogen bond present in haloalkanes, explain the mechanism of SN1 and SN2 reactions, and finally explain the mechanism of EN1 and EN2 reactions. Now, to begin with, let's start with this question: what is haloalkane? Now, haloalkanes it is a derivative of alkene in which hydrogen atom is replaced by halogen atom. Let's look at this presentation. For example, we have alkene here, we are adding this halogen there to the alkane, and we are removing hydrogen atom from the alkane, thereby we are getting haloalkanes here. Now, this our alkane, simple alkane, which is methane. We are adding bromine here. Now, as we can say, in this alkane, that's methane, one hydrogen is replaced by bromine here to give us bromomethane. So this is a haloalkane, and we are interested to study about this compound in this topic. Now, the most interesting thing about haloalkanes are the nature of bond that's present between carbon and halogen atom. So here, in haloalkanes, the carbon-halogen bond is covalent in nature with some polar character due to difference in electronegativity of carbon and halogen atoms. As we all know that halogens are highly electronegative elements, and when they form a bond with carbon, they tend to pull the shared pair of electrons towards themselves. As a result, they develop slight negative charge, and that results in the formation of slight positive charge on carbon atom. So halogen atom is more electronegative than carbon atom, hence carbon atom becomes slightly positive, and halogen becomes slightly negative in charge. So as we can see here, this are haloalkanes, and we are talking about this bond. We are interested to study about this bond. Now, we can see that the shared pair of electrons initially is exactly in between carbon atom and bromine atom. But since the electronegativity of bromine atom is higher than that of carbon, the shared pair of electron is pulled towards bromine. As a result, you can see these electrons are now more towards bromine. It is a polar covalent bond, polar single covalent bond. Hence, now you can see bromine develops slight negative charge due to pulling of those shared pair of electrons, and carbon develops slight positive charge. Now, because of this positive charge which is present in the carbon atom, it is highly susceptible for nucleophilic attack. Therefore, it can undergo nucleophilic reactions. When I say nucleophilic reactions, it can undergo nucleophilic substitution reaction, or it can undergo nucleophilic elimination reactions. Now, let's look at nucleophilic substitution reaction. What is nucleophilic substitution reaction? Now, carbon atom of haloalkanes are attached to halogen atom directly, has partial positive charge. The nucleophile approaches the carbon atom. The halogen atom gets displaced by the nucleophile along with bonding pair of electrons. This happens only if the incoming nucleophile is stronger than halogen. So let me explain here. Now, this is the incoming nucleophile here, and there is a bond between this. So as this nucleophile goes there, it displaces, it substitutes this halogen. From there, haloalkanes, and forms a new compound. A new bond will be formed between alkyl group and nucleophile, and in the process, halogens will be substituted. So as you can see here, from the lone pair of electron which is present in nucleophile, it will attack the carbon which is slightly positive in charge, and because of that, bromine will be substituted by the nucleophile. Now, I want to talk a little bit about nucleophile. What is nucleophile? Nucleophiles are any chemical species which is rich in electrons. So it will always attack the site where there is less electrons which bears positive charge. So now, as you can see, as it attacks the carbon which bears positive charge, halogens will be eliminated from here. So now, nucleophilic substitution reactions proceeds in the following way. First, it can proceed through unimolecular nucleophilic substitution reaction, which is known as SN1, or it can proceed through bimolecular nucleophilic substitution reaction, which is known as SN2. Now, we'll study about these reactions one by one. So first, let's look at SN1 reaction and its mechanism. Now, SN1, this one here stands for unimolecular and nucleophilic as substitution. Therefore, SN1 stands for unimolecular nucleophilic substitution reactions. And usually tertiary butyl halide undergoes this type of reactions. As you can see here, we have nucleophile here. This OH is a nucleophile. It goes there and substitutes bromine from there, resulting in the formation of alcohol, tertiary butyl alcohol, and KBr, potassium bromide. Now, why do you call it as SN1 reaction? Because it's a first order reaction. Here, the rate of reaction, even though we have two reactants, we have substrate and nucleophile, but the rate of reaction does not depend on both. The rate of reaction only depends on the concentration of alkyl halide, that is tertiary butyl bromide, and it does not depend on the concentration of nucleophile. That's why we have 0 here. Hence, it depends only on one concentration. We call it as unimolecular nucleophilic substitution reaction. Mechanism. Now, unimolecular nucleophilic substitution reaction, SN1 reaction, takes place through 2 steps. It involves 2 steps. So in first step, as you can see here, the breaking of carbon-halogen bond takes place heterolytically. When I say heterolytically, I mean the shared pair of electrons will be taken by bromine as this bond breaks. The shared pair of electrons will be going along with the bromine. As a result, bromine will go out as bromide ion, and it results in the formation of carbocation. This is a very slow step, and therefore it is a rate determining step for this reaction. Now, in second step, as you can see, the carbocation which is formed in step 1 is then attacked by a nucleophile, resulting in the formation of alcohol. This is tertiary butyl alcohol, and this step is very fast because it involves ions, and ionic reactions are always fast. Therefore, the second step do not determine the rate of chemical reaction here. So step 1, hydrolytic bond cleavage of tertiary butyl bromide, as you have seen already there. The tertiary butyl bromide undergoes hydrolytic bond fusion, resulting in the formation of carbocation, as you have already seen there. Now, this is a slow step, and it is a rate determining step. Step 2, as you have seen, attack by incoming nucleophile to the carbocation. The nucleophile from potassium hydroxide attacks the carbocation, which is formed in step 1 and produces tertiary butyl alcohol. So it is first step. So it's just the explanation of what we have already seen in previous slides. Therefore, the whole process is completed in 2 steps, forming tertiary butyl alcohol. All tertiary halides in presence of alkali undergoes SN1 reaction. Now, I want to emphasize on this one. All tertiary alkyl halide will undergo SN1 reaction. Tertiary alkyl halide will undergo SN1 reaction mechanism. Now, we'll discuss about SN2 reaction and its mechanism. Again, what is SN2? Here, 2 stands for bimolecular, and for nucleophilic as per substitution. Therefore, it is a bimolecular nucleophilic substitution reaction. Why do we call it bimolecular? Because here, unlike in the first one, where the rate of reaction was dependent only on substrate, here the rate of reaction depends on both the substrate as well as the nucleophile, which is attacking the substrate. Therefore, 2 molecules are involved in determining the rate of reaction. Hence, we call it as bimolecular nucleophilic substitution reaction. So, those nucleophilic reactions where the rate of reaction is influenced by both the concentration of substrate molecule as well as the attacking reagent is called SN2 reaction. It follows second order, as we have already discussed earlier, because the rate of reaction not only depends upon the substrate, but it also depends on nucleophile. As we have seen in previous slide, for SN1 reaction, it will not depend on nucleophile. That's why SN1, it depends only on substrate. But here, it depends on both the concentration of substrate as well as the concentration of nucleophile. Hence, we call it as SN2 reaction. Generally, as we have already discussed in previous slides, SN1 reaction, generally tertiary alkyl halide undergoes SN1 reaction, whereas primary alkyl halide will generally undergo SN2 reaction. Primary alkyl halide usually undergoes SN2 reaction. So as we can see here, primary alkyl halide in presence of aqueous alkali undergoes SN2 reaction, and the rate of reaction depends on both alkyl halide as well as incoming nucleophile. Hence, it is bimolecular, and it takes place in single step. It takes place in single step. Now, here, as we can say, this is primary alkyl halide, and then this is incoming nucleophile. It attacks and then results in the formation of compound, where we get this primary alcohol, which is methanol. Now, for this reaction, for SN2 reaction, it involves only single step. It involves single step, unlike SN1, which involves two steps. Now here, the incoming nucleophile starts forming a bond, a single covalent bond with carbon atom. At the same time, the bond which was already there between carbon and chlorine atom, halogen atom, starts breaking. Therefore, an intermediate state, an intermediate compound will be formed whereby partially new bond formation is taking place between carbon atom and incoming nucleophile, and at the same time, the old bond which was present between carbon and halogen starts breaking. And finally, the breaking of carbon-halogen gets completed, and the formation of new bonds between nucleophile and carbon gets completed and results in the formation of methanol. So this is primary alcohol. So therefore, unlike in SN1, where two steps are involved, here single step is involved, and it results in the formation of intermediate compound. So the nucleophile donates the electron pair to the substrate molecule, and simultaneously the substituent. Here, when I say substituent, we are talking about that halogen atom. The substituent withdraws electron pair from the substrate molecule. The whole process is completed in one step through the transition stage having carbon with 5 groups. That is this one, carbon with 5 groups. 1, 2, 3, 4, 5. But please remember, here the bond has not been completely formed. It is in the process of forming, and at this side, the bond is in the process of breaking. So here, unusually, carbon is having 5 bonds. Now, as we have discussed in the beginning, nucleophilic attack. When I say nucleophilic attack, it can be nucleophilic substitution reaction, or it can be nucleophilic elimination reaction. So now, let's discuss about nucleophilic elimination reactions. What are elimination reactions? Any reactions which takes place by the removal of atoms or group of atoms from a molecule to form multiple bond is called elimination reaction. For example, in this compound, when this bromine from this carbon and hydrogen from this carbon goes out together as HBr, this results in the formation of multiple bond, which is double bond in this case. Here, as you can see, it results in the formation of multiple bond. It forms multiple bond. When I say multiple bond, double bond, or it could be triple bond. So type of nucleophilic elimination reactions, again, like nucleophilic substitution reaction, nucleophilic elimination reactions are of two types. They are EN1 and EN2 reactions. So unimolecular nucleophilic elimination reaction and bimolecular nucleophilic elimination reactions. Now, let's look at EN1 reaction and its mechanism. Now, before we go inside, let's discuss what this EN1 stands for. It's both there. One stands for unimolecular and nucleophilic E elimination. Therefore, it is unimolecular nucleophilic elimination reaction. And Again, like SN1 reaction, tertiary alkyl halide or tertiary butyl bromide, hydrolysis of tertiary butyl bromide undergoes this mechanism or follows this mechanism. As you can see here, again, what's happening? This is going out. As it goes out from alpha beta carbon, again one hydrogen will go out and results in the formation of double bond between these two carbon atoms along with other byproducts. Here again, we are calling it EN1 because, as you can see here, the rate of reaction depends on the concentration of tertiary butyl bromide. You can see here 1, but it does not depend on the concentration of nucleophile, which is hydroxyl ion here. Therefore, it is known as 1 unimolecular because the rate of reaction depends on the concentration of only one reactant, that is substrate. It does not depend on the incoming concentration of the incoming nucleophile. And all tertiary halides in the presence of alkali undergoes EN1 types of reactions. Again, like SN1 reaction, again I'm going back, like SN1 reaction, EN1 reaction also involves 2 steps. So in step 1, again, there will be breaking of carbon-halogen bond heterolytically. Heterolytically because as this bond breaks, both the shared pair of electrons will go along with bromine as bromide ion, resulting in the formation of carbocation. This happens in first step. Now, in second step, the incoming nucleophile, which is here, will take this proton and this bond will go inside, results in the formation of double bond. So now you can say that it results in the formation of 2-methyl prop 1 in. 2-methyl 1 to 2-methyl prop 1 in. So EN1 reaction and its mechanism. First step, hydrolytic bond cleavage of tertiary butyl bromide, that's tertiary halide. The tertiary butyl bromide undergoes hydrolytic bond fission, resulting in the formation of carbocation. That's what happens in step number 1. And it is a slow step, and therefore it is a rate determining step. It's a first order reaction, as we have already discussed, because it depends only on the concentration of substrate. Therefore, the whole process gets completed in 2 steps, resulting in the formation of product. So it takes place in 2 steps, EN1. Now, step 2, removal of proton. So EN1, first we have discussed about the formation of carbocation. Now, we are talking about the removal of proton from beta carbon or removal of beta protons. So the nucleophile, that is hydroxide ion here, from alcoholic potassium hydroxide attack carbon atom adjacent to carbocation formed in step 1 and removes the proton, producing methyl prop 2 in, which has unsaturated compound because of the presence of double bond. Thus, the whole process is completed in 2 steps. Again, let me take you back a little bit. Yeah, let's go back to this one. In first step, the breaking of carbon-halogen bond takes place heterolytically, resulting in the formation of carbocation and bromide ion. And this is a slow step. It is a rate determining step because slow steps always determines the rate of a chemical reaction. Now, in second step, the incoming nucleophile removes a proton from beta carbon. Removes a proton. When this proton is removed, the bond goes inside. As a result, it results in the formation of a compound with multiple bond, that is, with double bond in this case. So we have completed EN1 reaction. Now let's look at EN2. Again, what does EN2 stand for? 2 stands for bimolecular, N nucleophilic, and E elimination reaction. So it stands for bimolecular nucleophilic elimination reaction. Like SN2, here primary alkyl halide usually undergoes this type of reaction when it is attacked by a nucleophile, and it is known as bimolecular because the rate of reaction here depends on the concentration of substrate as well as the concentration of incoming nucleophile. Since the rate of reaction depends on the concentration of 2 reactants, both the substrate as well as the incoming nucleophile, it is known as bimolecular nucleophilic elimination reactions. And as you know, that all primary alkyl halide in the presence of alcoholic alkali undergoes EN2 reactions, and then it is bimolecular. Now, as you can see this here, the reaction It just goes there. This bromine along with one of the hydrogen from this carbon is removed completely, resulting in the formation of ethene, or resulting in the formation of multiple bonds along with other byproducts. Now, like SN2, En2 also takes place in single step. En2 reaction takes place in single steps. So now what happens here? You can say the incoming nucleophile is attacking a proton. At the same time, the bond comes in, resulting in the formation of double bond, and bromine ion, a bromine atom comes out from here, resulting in the formation of bromide. So this is intermediate compound where the bond is formed between this hydrogen atom and incoming nucleophile, as well as this bond is has just started breaking, and finally it gives the product, which is ethene along with other byproducts. So again, like SN2, En2 also takes place in single steps, and it results in the formation of intermediate compound, or it results in the formation of intermediate state, which then later gives a product with multiple bond. It can be double bond or it can be triple bond. So the nucleophile removes a proton from the substrate molecule, and simultaneously the substituent, that is halide, withdraws electron from the substrate molecule, forming double bond in this case, and therefore it is unsaturated compound. The whole process is completed in one step. So basically, when you talk about 2 and 1, SN1, En1, they take place in 2 steps. They involve 2 steps, whereas SN2, En2, they involve a single step. And both these reactions results in the formation of intermediate state, whereas SN1, En1, they do not involve the formation of intermediate state. Again, SN1, En1, usually tertiary alkyl halide, like tertiary butyl halide, undergoes this type of reaction, whereas primary alkyl halide undergoes En1 or En2 reactions. Now, before we go to this question, I want to summarize the whole lesson that we have learned in today's class. So let me use the board to explain what we have covered so far. So the topic, substitution and elimination reactions of haloalkanes, as we have already discussed. Now, we have discussed that in haloalkanes, the shared pair of electrons will not remain in the center, but it will be pulled more towards halogen, because halogens are more electronegative compared to carbon atom. Therefore, these halogen atoms will develop slight negative charge, and this carbon will develop slight positive charge. Now, this is of interest. Because of this positive charge carbon atom, it is highly susceptible to nucleophilic attack. Again, as we have discussed, what is nucleophile? We have already discussed. Nucleophiles are electron-rich species. Nucleophiles are electron-rich species. They will always attack the center which is positively charged due to presence of excess electrons in them. If I give you some examples of nucleophile, water is a nucleophile because it contains 2 lone pair of electrons in oxygen atom. Ammonia is a nucleophile because it contains 1 lone pair of electrons on nitrogen atom. These are neutral nucleophiles. Again, we can have other nucleophiles like OH minus is a nucleophile due to presence of lone pair of electrons here, or even Cn minus, these are nucleophiles. So this carbon atom, which bears slight positive charge, is susceptible to get attacked by those nucleophiles. Hence, it can undergo nucleophilic substitution reaction, or it is susceptible to undergo nucleophilic elimination reactions. Now, nucleophilic substitution reactions, again, as we have discussed, are of 2 types, that is SN1 and SN2. Now, briefly, what is SN1? It stands for unimolecular nucleophilic substitution reaction. What type of alkyl halide undergoes? Tertiary alkyl halide undergoes this type of reaction, it involves how many steps? Number one. Number two, involves 2 steps. Involves 2 steps. Whereas here in SN2 reaction, usually this type of reactions are undergone by primary alkyl halide, and it involves only single step. It involves single step. Here does not involve the formation of intermediate compound, whereas this involves the formation of intermediate compound. Similarly, if you look at EN1 and EN2, let me just briefly go through this one, EN1 and EN2. It's more or less same. Okay. EN1 reaction mechanism will be undergone by tertiary alkyl halide. It favors those compounds, whereas EN2 reaction mechanism, it generally favors primary alkyl halide. So primary alkyl halide will undergo EN2 reaction mechanism, whereas tertiary alkyl halide will undergo EN1 reaction mechanism. As we have discussed, 1 stands for unimolecular and nucleophilic elimination reaction, bimolecular nucleophilic elimination reaction. Again, this involves 2 steps, whereas this involves only 1 step. Again, in this one, first step, breaking of carbon-halogen bond, and second step, formation of multiple bond. Here, it takes place by formation of intermediate compound. So with this, we have almost come to the end of our lesson. I hope you have enjoyed the lesson. Before we end the lesson, I want you to go through these questions. Let's look at these 3 questions. First question, write 2 differences between SN1 and SN2 reactions. Number 1. Number 2, why do tertiary butyl halide undergo SN2 reaction and primary alkyl halide undergo SN1 reaction? As we have already discussed, it's always tertiary alkyl halide that undergoes SN1, whereas primary alkyl halide undergoes SN2. Why they undergo this type of reaction? This is question number 2. And third question is, why does the slowest step determines the rate of a reaction? Always, why it is the slowest step that determines the rate of a chemical reaction? Why not the fast step? So this is the third question. Please explore through different resources, get the help of your maybe respective chemistry teachers, and then answer these questions. Thank you. I hope you have enjoyed this lesson. See you in the next lesson.